So today we're going to do section 2.3, approximations of trigonometric function values. And this is going to be a calculator section. So in 2.2, we did the exact value. We did not approximate. We drew triangles with root 2s and root 3s. We found exact values. But in this section, we're going to find approximations. So when we do approximations, it's an about value, not exactly. Make sure that you read the yellow boxes that are in your notes. So this yellow box says, it is important to remember that when we are evaluating trigonometric functions of angles given in degrees, that our calculator must be degrees. So to be in degrees, right next to the second button, there's a button that says, on the calculators of my classroom, it says DRG. And when you press it, you just want to make sure that you have degree highlighted and you press enter. If you don't have the exact calculator in my classroom, it is possible that you have to press the second button, and then next to the second button, there might be a button that says mode on it, or maybe you just press the mode. It depends if the mode's in the purple color or not. And then it'll have words like radian, degree. Make sure that you're in degree mode. Also remember that if the angle or the reference angle is not a special or quadrantal angle, one that we're going to memorize from the unit circle, that you always have to use an approximation. So another way to think about this second piece is if it's not a 45, 45, 90 triangle or a 30, 60, 90 triangle, or if it's not one of the what we call in polars, the poles, the XY plane, the axes, the X, the negative X, the Y, and the negative Y. If it's not one of these things, then we have to use the calculator and find an approximation because it's not a memory value that we make you put in your brain and not use a calculator for. So let's start off and do these problems. So example 1 says, I have sine of 49 degrees and 12 minutes. So the first thing to do is you need to convert this angle back to degrees. So you're going to do 49 plus 12 over 60. In your calculator, you want to type 49 plus parenthesis 12 divided by 60 and close the parenthesis. This gets you a nice perfect number, 49.2, and then make sure you're in degrees. You can type in your calculator sine, and then you're going to type 49.2, and it should spit out an answer for you. And we're going to use the approximate symbol, because it doesn't equals, it's approximately 0.75699,506. Make sure in your homework that you are reading directions so that you round and write the appropriate amount of decimals in your answers. Letter B, we can't put this in the calculator because we don't have a secant button. So in my calculator, I have the option of doing 1 divided by parentheses, secant's friend is cosine, so you can do it like this. So go ahead and try that. When you do, you should get out that it is negative 7.20587921. Another option you can do, so this is option 1. Option 2, you can type cosine of the 97.977 degrees. And once you do that, there's a button on your calculator that says x to the negative 1. What that button does is it flips things over. So it is the reciprocal button. So it takes the value that you get out of cosine and does 1 over that number, and you should get out the exact same thing. The next one looks scary, but if you remember that 1 over cotangent is actually equal to tangent, because tangent is cotangent's reciprocal. So you can just type tangent of 51.4283 degrees, and you should get approximately 1.253948115. The last one, it's just sine of an angle. It's just not a 30, 60, 90 special triangle angle. So when you type it in, you should get 0.91354546. I've mentioned this before, but I'll mention it one more time. At this point in this math class, we don't know anything about sine to the -1 power. So please make sure that you are not using these buttons. These buttons on your calculator, the cosine to the -1, those are bad buttons right now. Please don't use them. They are what we call arc or inverse functions, and that is not what we're learning right now, so don't touch them. They are bad, bad, bad. Those buttons are bad, bad, bad until you get to the next page. So let me just have a little thought bubble off to the side here. So what we've been doing is I'm going to use nice, pretty numbers. Sine of 30 degrees, if you type it in your calculator, comes out to be 1/2. The questions we're about to do are going to ask us sine of what angle, theta, we don't know, equals 1/2. To undo the sine, you can't just divide by the sine. The sine and the theta are connected. So to undo that sine and magically make it move over here, we have to undo it, not just divide by it. So to undo it, we do an arc sign like this, which is the sign to the -1 button. If you do that on one side, then right here on the other side, you're going to do arc sign the -1 with the 1/2. So when you do that, you get theta all by himself equals, we read this as arc sign of 1/2. And then it will spit out to you that theta equals 30 degrees, if you're in degrees. So we're going to use this, and we're going to do example 2. So the question is asking us sine of theta equals this decimal. What is the decimal? And what is the theta? And they want the answer that you're going to give back to them in this restriction. So to undo this sign, we do the arc sign on both sides. So that gets us that theta equals arc sign of 0.967700915. So you're going to grab your calculator, and you're going to press the second button and the sine button. And so on your screen, you should now have that sine to the -1 with an open parenthesis, and then you type this in right here. The calculator is going to approximate an angle back out for you, and it's going to be 75.3999995 degrees. So let's try the next one. The next one, I just want to warn you about the sines and the cosines and the tangents have an arc button. It's very clear cut. I would not touch the calculator if you have a secant, cosecant, or tangent. I would rewrite this. This thing is equal to 1 over cosine theta equals 1.05455829. So in theory, I'm going to multiply this cosine over here, and then I'm going to divide the 1.05455829 over to the other side. If I do that on one side, I have to do it over here. So what I end up getting is that 1 over 1.05455829 equals cosine theta. Then I'm going to do the arc of both sides. So I'm going to have arc cosine, the cosine of the -1 of 1 over 1.05455829 equals my theta. So in your calculator, you're going to press second and that arc cosine button. Then it opens a parenthesis. You're just going to press 1, divide by, and you're going to type the 1.05455829, and it should spit an answer back out to you. So theta is approximately 18.514704 degrees. So some notes about inverse and reciprocal functions. 1 over anything is a reciprocal. Any trig to the -1 power is an inverse. We're undoing the trig function. When you do this, you are solving for theta, the angle. So notes about rounding and decimals, I've mentioned it once, I'm going to mention it again. Make sure you read the directions. And you give back what's given to you. So if the problem's in degrees, make sure you stay in degrees, and if it's in radians, then you're going to be in radians. But you don't want to change angle measures unless the direction asks you for the answer in a different measure. So now let's do a couple word problems. I know, your favorite word problems. This is a physics formula. Work equals W of force over sine of an angle. So the automobile travels uphill or downhill on a highway. Uphill or downhill is called the grade. The incline on a road is called the grade. It experiences a force due to gravity. This force F is in pounds, is the grade resistance. So there's, like when you go down the hill, the earth is pulling on the car more, so it accelerates. But when you're trying to go up, there's more resistance, and it's harder for the car to go up the hill. You need more acceleration. When theta is the grade and W is the weight of the automobile, if the automobile is moving uphill, then theta is greater than 0. If the automobile is going downhill, it's less than 0, because we measure everything. We measure everything from this positive x right here. So going this way is a positive theta, and going this way is a negative theta. Calculate F, the force, to the nearest 10 pounds. So make sure you read 10 pound for a 2,500 pound car traveling uphill at theta equals 2.5. So this is my W, and there's theta. So the formula says F equals W sine theta. F equals 2,500 sine of 2.5. Make sure you're still in degrees. You type in the calculator, but make sure you give out to the nearest 10 pound. So the nearest 10 pound is 110 pounds. Make sure that story problems have story answers and that you label them appropriately. The next one says that it wants us to calculate F to the nearest 10 pound for a 500 pound car, and this time my theta is a negative. I'm going downhill. So F equals, my W is 500 pounds, sine of negative 6.1 degrees. So you type that in your calculator. Make sure you put the negative in front of the 6.1, and make sure you use the negative button like this on your calculator, not the minus button. Otherwise, it'll say syntax error. You got to use that negative button. It's down in the keypad part, not on the side with the plus and minus buttons. And when you do, to the nearest 10, negative 53.13 pounds. It says round to the nearest 10 foot, so negative 50 pounds. Then it wants us to calculate F for when theta is 0 and theta is 90. So we do 500 sine of 0 degrees. Sine of 0 degrees over here is equal to 0, so the force is equal to 0. But if I do F equals 500 sine of 90, 90 is straight up, so the force is equal to 500. And so it says, does this agree with your intuition? So if I'm pulling straight sideways, I don't need to worry about the grade. There's not going to be a resistance or something that's going to increase or decrease. So my force is equal to nothing because I'm not going to go anywhere. But with going straight up and down 90 degrees, gravity is what pulls you up and down. So the force, your weight, is equal to exactly that. There is no side to side. It's just straight up and straight down. So it does absolutely agree with my intuition.